I'd like to welcome back Paul Shapiro, who will be walking through opportunities to work smarter through the use of automation.
Thank you. All right, that's a tough act to follow. Seriously, Russ, that was awesome. You guys already know who I am from earlier, so we'll skip past the giant photo of me. I'm going to talk a little bit about automation, and I'm going to sort of breeze through this so we have some time, extra time for our amazing speakers. But why automation? The most obvious reason for automation is we're able to work faster and free up time for more important tasks, things that can't be handled by a machine. But there are two other reasons why automation really helps as well. We have the ability to look at more data because we're not doing things manually. That allows us to just look at a larger data set. Also, it allows for improved consistency and procedure. If you're automating something, that means you can do the same exact thing over again in the same exact way. So there's benefits there as well. So what can you automate? If you're doing anything that is being done on a routine basis, then it's probably a good candidate for automation. Doesn't always mean that you should automate it, but it means that it can be automated. Any procedure that can be broken down into sort of smaller micro chunks, micro tasks, and that can be strung together, those are things that can be automated. And with the incredible ease of using machine learning nowadays, even some of those more complex tasks have become easier to automate. So how do you automate? Most of this presentation, I'm going to be talking about things you can automate rather than how to, but I'm going to go through just a quick how to. For us, we love this tool. It's called Nime. So you can get that through nime.org. It's free and open source. And what I really like about it is it's literally this drag and drop interface. So the barrier to entry is very, very low. So even some of our non-technical staff can get their feet wet and start playing around with it. And it's completely free, and there's this huge library of things already built into it. And of course, there are other options. We are platform agnostic. You can use your favorite programming language to do a lot of your automation. So I certainly encourage that as well. So that's one part, a scripting language or Nime. The other part is a scheduling system, something like Cron. So what is Cron? Cron is a Linux, Unix scheduling daemon. So you can literally set it up to run repeated tasks at a certain time on a recurring basis. The Windows equivalent is Windows Task Manager. Just a quick how-to use for Cron. This is an example of a command for Cron. You put this into your terminal or your command prompt, and it is 5 asterisks, which coincide with day of the week, month, day of the month, hour, and minute. So for instance, 001 asterisk Python data collector.py would represent running the Python script data collector.py once every month at midnight. Okay. Talk a little bit about the basics of Nime, just because I want you guys to be able to walk away with some tools, things you could actually do tomorrow. So Nime is composed of what are called nodes. They are exactly what I talked about as the basis of automation. They are little drag and drop components that you literally take them from a panel on the left and you drag them into a window. And you string them together and they do more complex things. It's this easy. See, you take it from the left and you drag it over to the right, and then you connect them together. And then each one gets configured individually, or you can use something called a meta node and configure them in unison. And then you click run. Super, super easy. All right, so now let's go through an example of something we could automate this way with keyword research. So most keyword research you see looks like this. It's an Excel spreadsheet. It's nothing too exciting. And it's actually a huge time investment. And as I mentioned already, because you're doing this very manual process, you have a small data set you're working with. We automate it, we're able to look at a larger data set. So this is sort of like the logic behind some basic keyword automation. You start with a list of keywords. You can use this from various sources, things like just a few ideas you have at the top of your head. You combine that with the Search Console API and pull in data that way. Take data from SEMrush. SEMrush is a great resource for data. If you're doing a lot of AdWords campaigns, you can use an SQR report. You're just creating a foundation, a list of seed keywords, basically. And then you filter that into some very obvious things you can use, like Keyword Planner API. You can do this via the grepwords API. Thanks, Russ. You can do some semantic keyword research. You can do some of that stuff in KNIME yourself, or you can use a tool like MarketMuse, which does really great semantic keyword research, and it's a great tool for that. Do that via an API, and then you can add on things like the SEMrush and sort of look at your competitors with that way. So you take all that data, and then you filter that into something like the Google Autocomplete API. So you're just constantly expanding your data pool. And finally, you sort of finish this off with a series of filtering of your data and manipulations of that data. So some sort of data manipulations to be thinking about. You can do things like get the top 10 results via a rank tracking service, do this via an API, and then you filter that into the Moz API, and then you get a competitive data set because you can average the page authority across all those ranks. You could also use something like SEMrush's keyword difficulty API or another similar service. Search volume, you again get that through grepwords. You can do things like look at Google Trends data and sort of try to calculate slope and see what the projection will be looking like in the future, making sure that that keyword actually has a potential to grow rather than decrease. And you just sort of string all this together, and at the end of the day, you have this really wonderful data pool, and then you have to do something with it. So instead of relying on that Excel spreadsheet, I advocate visualizing it. So do a simple graph like this, something like organic competition by growth and then sized by search volume. And this allows you to sort of make very dynamic decisions on the fly about keyword research. And I recommend using something interactive, so that could be a Tableau or a Google Data Studio or Power BI, something along the lines of that. Also provide this option. You can use like a Python script. Use like the Boca library. Boca library does the same thing. It creates like an interactive visualization. It's pretty cool. And that's the script made available if you guys want that. And if you want to learn more about specifically automating keyword research, these are the two resources you should be looking at. I give another presentation at Search Love about this in more depth. There's also a Bread and SEO presentation I gave about specifically semantic keyword research. Okay, so what else can we automate for SEO? Go through a few quick examples. I think the most obvious thing you should be thinking about automating is reporting. If you're spending, I remember my first SEO job, and we spent hours upon hours making reports in Excel. That's really dumb because this is really, literally something that should take you like 5 minutes to do. So we're bullish on Tableau. We do all our reporting in Tableau nowadays. We have a series of data collectors, and we automatically push that out. Data collection. Do your data collection. So for instance, I'm a big fan of collecting Google Search Console data via the API. I have a Python script available on my website. J.R. Oaks, one of our speakers later, also made a really awesome script using Google BigQuery if you want to store your data that way. 301 mapping. This is a cool example of something I did. I want to thank Patrick, who sort of is responsible for this idea. Just go through the logic. So We take a crawl of the current website. We download all the rendered pages from that crawl. We extract only the main content. So we get rid of all the boilerplate stuff using the boilerpipe API, which is a Java library. And we convert it to a bit vector. That's step one. Step two is we get historic URLs from the Wayback Machine API. If you ever use the Wayback Machine API, it's like incredible. You see so much stuff that you missed, things that have gotten lost over the years in terms of URLs. Then you filter out everything you found in the current site from the crawl earlier. You grab the rendered pages from archive.org, the Wayback Machine, extract the main content of that, convert that to a bit vector, and then you compare them with cosine similarity, and then you could pretty much automatically generate like HT access strings. So you just automated 301 redirect mapping. And just because I said a bunch of like jargony words right there, oops. Just want to show like within KNIME, for instance, there are a number of tools to make this a lot easier. For instance, there's a node specifically for vector conversions and doing those cosine similarities. So it's very easy for you to get started with that yourself. SERP similarity. This is an example that Reed came up with, actually. So it's something we download all our ranking data for a set of keywords via the stat API. So we get the top 10 results for all those keywords, and we literally compare them to one another. So we know for keyword A and keyword B, the SERP's actually identical or close to identical. And we can calculate the percent similarity, and then we can actually do things like schedule checks. So every time a new keyword emerges that we want to compare to that, we'll know if something changes that way. But we might also look at old keywords. So if something was 100% matched before, and then all of a sudden a new site starts ranking, and the content on that is distinct, and we get a notification about that, that's a good indicator that maybe we want to start thinking about some new content or to expand on existing content for that search result. You can do things like testing JavaScript rendering. So, search GitHub. There's a lot of cool stuff on there. Here's a script in the corner. This is a crawler. So with Node.js, it's using Puppeteer, which is the Chrome headless browsing automation script that they released. It will crawl all the pages on a JavaScript website, and then you can extract things like the titles and make sure everything's rendering correctly. Performance testing with Lighthouse. Here's another script. You run this with Node.js, and it'll get you all those new fancy Lighthouse metrics for performance, like time to first paint and TTI. Although I was speaking to Pat Meenan yesterday, and he said to hold off on that, so that's sort of interesting. Anomaly detection. I wrote an article about this on Search Engine Land, but the basic idea is we're looking for anomalies in click-through rate. You collect a bunch of data from the Search Console API, you round to the average 10th position, and you identify outliers using statistical methods like modified z-score or interquartile range. That way we get email notifications on a recurring basis to see if something sort of falls out of the expected click-through rate, which means maybe one of our practitioners should take a look at it. Maybe our title tags aren't on spot. Maybe there's a new SERP feature that are impacting click-through rates. Either way, we're getting notifications and we can act on it instead of leaving it. Content ideas. You can do things like mine Reddit. It's a Python script, again, if you guys want to do that yourself. And Ruth, you can share that this time. I had shared this previously, and I asked Ruth not to share it. So this is pretty simple. You just sort of choose an output file. You put it in a search term. I would set this to new in this case. So you're only getting new results for a keyword. And you can either choose to look at all of Reddit or a specific subreddit. And then you run this on a recurring basis. So that way you're getting all these really fresh ideas from like a social network, and you're doing a form of social listening on on a network that virality is really key, and people are really creative in doing interesting things. AMP validation. Personally, a lot of people are relying on AMP validation with Google Search Console. It's really slow, and the other tools that they provide are really only for like one URL at a time. It's not great. So you can use the AMP Bench API and sort of do this in bulk and make sure all your AMP pages are validated. So you can do that on a recurring basis. Just schedule that with Cron. Link building. Russ talked about this earlier as well. Link building is not immune to technical SEO. Very simple example, just use an API like the Ahrefs API and put your competitors in there and make sure you're getting notifications about new prospects. And just to finish it off on the last idea, tons of tech audit related site changes, type of things you should be monitoring automatically, things like making sure new 404s, you're getting notifications about that, any new to redirects, anything your clients shouldn't be doing and are, like they always do. Any sort of changes, indexation, anything that would go into a tech audit, I think is fair game to receive notifications about. And we have our own site crawler for this built in Nime, but we also leverage things like the deep crawl API for that. It's something you can also do. All right, that's it. I think we still have some time left over. So I could ask maybe like a quick question if anyone has. Yes?
Are you running Nime locally or in like an AWS box?
Yes.
Both?
Yes. We're running it locally and on a server cloud. So yeah, it's what we're specifically doing for the click-through rate thing that I mentioned. We're looking at we're using the Search Console API and we're extracting the keyword data associated with the landing page. So we're seeing for each of those pairs, if one keyword is ranking, say like position 1.2 from Search Console, we look at the whole corpus of things ranking 1.2. And we're seeing if there's an outlier there. So for this specific keyword pair, if that makes any sense. Give an example. Yeah. So if I don't know, SEO conference is ranking in position 2, and I have our page specifically at position 2, and we have a whole bunch of other keywords that are ranking in position 2, and the click-through rate for those is much higher. That's a red flag. That's something we should identify so we can course correct.
And you're correcting like title tags essentially and description?
What we're doing is we're creating notifications so we can look into it, because oftentimes it might be like our title tag is not the best and could be better, and that's something we can act on, but oftentimes it's also like, there's a new knowledge graph, and that's just taking away from the click share. So it's on a basis by basis. Depends on the case.
Thank you.
Yeah. Yes.
Are you using Nime just to like prototype things, or are you running that at scale? What's the line between kind of?
We're doing a bit of both. So we are running it at scale for certain things, and we're also using it to prototype.
How scalable the mbench API is? Like, is there any limit, like a daily limit or something?
That's fair. So the script I used actually uses it's like the AppSpot endpoint that they provided. Probably shouldn't be using that, but you can run it locally, so it should scale quite fine if you run it locally.
Okay, cool. Because it's really interesting. We could use also just like rendering the page and looking at the JavaScript console output. The problem with that is that when the AMP JavaScript library makes changes to the specific output, you have to change your script to also match that. So using the AMP bench might be a better solution.
That's one of the problems
as long
with
as
AMP.
it's scalable. Yeah.
Yeah.
Thank you.
Okay. I think we're good to move on to the next speaker. But thank you, everyone.